So give the heading as Antarctica now. Opposite of Arctic is Antarctic. Okay, all of you know. South Pole, 90 degrees south. Okay, Antarctica is the continent, fifth largest continent. Fifth largest continent. Fifth largest continent. So please notice that fifth largest continent is Antarctica. Okay. Antarctica is surrounded by ocean called Southern Ocean. Please notice it is surrounded by ocean called Southern or Antarctic Ocean. Southern Ocean. Antarctic Circle, 66.5 degrees south, passes through Antarctica and the surrounding ocean. It passes through the surrounding ocean and the continent. It is a continent. Okay, please remember this. Covered with ice because its location is South Pole. It was earlier part of Gondwana land. Please write. Earlier part of the Gondwana. Gondwana. Since then it is there only in that location. Where? In the South Pole. Because of that it has received snowfall year after year, year after year. All that snow has accumulated forming a large mass of ice. In our glacial landforms I have told you, any place with more than 50,000 square kilometers of ice, it is called as ice sheet. Ice sheet. What is ice sheet? More than 50,000 square kilometer area. Ice cap, ice sheet. More than 50,000 square kilometers is called as ice sheet. Less than 50,000 square kilometers is called as ice cap. So Antarctica is a large mass of ice sheet. Okay, please remember, means on a continent. Because of the presence of ice over a large area, it is the highest average elevation among all continents. It has the highest average elevation. Highest average elevation. Please remember this. Highest average elevation. Settle down first. Highest average elevation means in terms of elevation. Highest average, they will ask you which of the following continents has the highest average elevation? Africa, Asia, Antarctica, South America. Antarctica. In terms of elevation, average elevation. Okay. Because it is covered with ice overall. So it's a large mass of ice here. Remember, when the glacier melts, what happens? The mass decreases. So the land continent keeps rising slowly upwards. Isostatic adjustment. Remember isostatic rebound. Isostatic rebound. Antarctica is experiencing isostatic rebound now. Antarctica is experiencing isostatic rebound due to melting of glaciers. Sit down, sit down. Just make him some space now. This is not first standard. You make some space, get some. You can sit in front. Go. Come here, come here, come here. No, I know. You sit down. You're not the problem. He's the problem. I'm telling him. I'm not telling you. I'm telling him. See, I have a lot of patience because earlier I was teaching school kids up to 5th standard. So I know how it is. I was a part of the NGO earlier. So I was teaching like this kids. You know what they do? They sit like this, jump on the chair and all. We can't do anything. So I have that patience. So isostatic rebound is when the glaciers melt, overall elevation of the land goes up. Because notice this is the land on which there is large mass of ice for many millions of years like this. So that load will be there. I'm not talking about 1 or 2 kgs. I'm talking about tons of ice load. Okay, if you pick up any mass of ice, you'll know it's very heavy. Ice is very heavy. So tons of ice is here. In many places, from the surface to the top of the glaciers, 4 kilometers. 4 kilometers of ice is there. You can imagine, means entire area if you calculate, it's billions of tons of glaciers. Such a load was there. So because of the load, what has happened? Antarctica had gone down. Now ice is melting. What happens when the ice melts? Load is reduced, so it comes back. Just like you are sitting on a sofa with a load. So sofa goes down. Isostatic adjustment. When you remove the load one by one, you get up. What happens? The sofa rebounds. Isostatic rebound. That is causing a lot of earthquakes in Antarctica. And one of the reasons for the glaciers to break. in photos, videos, they will be showing, oh, ice is breaking on Antarctica, global warming and all. They'll be showing why that ice mass is breaking so fast, because of the isostatic rebound. Remember the class isostasy we have discussed. So remember Gondwana, that part. So it's a large mass of ice. Since it is covered with ice, it is called as a cold desert. Cold desert. Antarctica is a cold desert. Antarctica is a cold desert. Antarctica is a cold desert. Since it is covered with snow, glaciers, it appears white in color. Notice the atlas. Page number 101. Notice Antarctica, how it looks. So Antarctica is called as a white continent. White continent. Cold continent. Cold continent. There are places in Antarctica where the temperatures go up to minus 220, minus 230, but uninhabited. Nobody lives here. Okay. So as a result, we don't have to worry about this place. So white continent, cold continent is the largest desert on earth. It is bigger than Sahara. Sahara is hot desert. This is cold desert. If they ask you in general which is the largest desert, if they give option as Antarctica, answer should be Antarctica, because it is bigger than Sahara. Bigger than Sahara and Gobi. Okay. Sahara, Gobi combined is Antarctica. Very big. Okay. Cold desert. White continent. But also notice, it is ice, means what? Fresh water. Largest reservoir of fresh water. Please write. Largest fresh water source is Antarctica. Okay. Remember, ice, 69% of the fresh water is in the form of ice. And Antarctica counts for the majority. Remember one pie chart we wrote in the starting classes, 3 pie charts. Water 97% saline, 3% fresh. In fresh 3%, I told you ice is the majority. This is the one. Majority of the world's fresh water is in the form of glaciers, ice. What many companies are doing in Antarctica now, let's say US based companies, they are going to Antarctica, they're dragging mass of ice, chunks of ice. They are melting it and bottling it. And they're selling it as pure water, glacial water. And they're charging $20 for that. That's the business now. The glacial water only, directly they are bottling it. You got it? So that has become a business in many countries. If you go to Europe or big malls here only, big malls, there is a shopping mall. They'll sell 250 rupees ka water bottle. This only this much. You'll be wondering why 250 rupees. Outside you get tap water, correct? Or water everywhere. In India, not a problem for water. Drinking water is available. But here 250 they are charging. 300 rupees they are charging for water bottle. Why? Because glacial water they are giving. So that has become a business now. So now Antarctica is in threat because of that also. Nothing. I have tested. It's same, almost same. Okay. So there is no benefit as such. It doesn't contain any minerals. The regular water we get is mineral water. Some minerals are added. Potassium, magnesium are added in the water we have. This doesn't have that. Okay. No benefit as such. So since it is millions of years of old ice they are talking about, so they call it as a kind of very pure water and all. Okay. So remember, now let's see the place now. Notice the Antarctica. Notice it is close to South America. Antarctica is close to South America. South America. Which is the continent closest to Antarctica? So see here. Yeah, please come. Come here only. Notice this, please. This is Drake's Passage. Okay, pay attention. This is South America and Drake's Passage. All of you see here. Remember South America yesterday's class? Drake's Passage. Check place. Drake's Passage, all of you. Drake's Passage. Drake's Passage. This is all Southern Ocean, Antarctic Ocean. See, in one of the batches I was teaching earlier, I'm talking about 2008-9. There were like group of students like this only, like just you, like you all. So one girl in the class, correct, she was harassed by almost everyone, like this. So kind of you can teasing, bullying and all. After few years passed by, like the same class group of batch, you know how you're like all sharing contact numbers and all. She went on to become IAS. She went on to become IAS. Okay, deputed in Mysore district. So I was there. So in the same district, I didn't know the same batchmates were also there. One as a sub inspector, one as a excise sub inspector, one as a FDA, SDA and all. But she was IAS, DC Mysore. She invited me for a Republic Day function. I was there and I met almost 5-6 in the batch. She was the head of the district and all the other students in the same batch, they were in other post but lower than her. She used to harass them now. I was never, you know how people are, they hold on to grudges. And I never thought, that too, she's a woman. You can understand now what she did. She went on. I respect her for that. I respect her for that. And she invited them also, because usually they don't come. Only the district management will be there. From across those district, she invited them also. So Mohan sir is coming, come over. Then I met them all. So seeing how the seats change. You got it? So then the situation turned out to be like, for them, they were looking at me like this. So she was there in front of all of them. So things were like that. So be careful who you bully. You never know. Correct? How the things change. Okay. It becomes very tough. So South America and Antarctica के बीच में we have Drake's Passage. Drake's Passage. Okay. And all the surrounding water bodies you see. Weddell Sea, Scotia Sea and all. Notice the water bodies here. Scotia Sea, Weddell Sea, Amundsen Sea, Bellingshausen Sea. Around this, you can notice lot of water bodies. Small Ross Sea. Around the Antarctica, you notice. Bellingshausen Sea, Amundsen Sea. Around Antarctica, we get lot of water bodies. See here. Amundsen and all. Okay. Weddell Sea got. Davis Sea. Ross Sea. Okay. Amundsen Sea. Bellingshausen Sea. All these are the surrounding water bodies of Antarctica. So exam mein this was asked. Weddell Sea was asked, Scotia Sea was asked in the UPSC paper. Because there is a plate called Scotia plate here. Scotia plate, minor plate. Okay. Scotia plate is between which two plates? South America and Antarctica. Antarctica is a very large continental plate. Antarctica is a large continental plate. And in Antarctica you can see here, this is the mountain range here. Trans-Antarctic mountains. Trans-Antarctic mountains. Trans-Antarctic mountains. Okay, this mountain range divides Antarctica into two parts. Two parts. Greater Antarctica, Lesser Antarctica. Greater Antarctica, Lesser Antarctica, or Eastern and Western. Eastern and Western. Please notice Trans-Antarctic mountain, which is the mountain range that divides Antarctica into two parts. Transantarctic mountains. Okay, greater, lesser. Here we have Ellsworth Mountains. Ellsworth Mountains. And a peak called Vinson Massif. Highest peak. Vinson Massif is the highest peak of Antarctica. Yes, across this is Atlantic Ocean, Pacific Ocean, Indian Ocean. But today they are called as Southern Ocean. South of India, south of Pacific, south of Atlantic is called as Southern Ocean. Is that's what. So because all that is today combined into an ocean called Southern Ocean. If you are using Orient Black Swan, there they have given. But in other oceans, they have given Southern Ocean. Oxford and all. Okay. But it is now called as Southern Ocean or Antarctic Ocean. Okay. Now see here, all of you. This part, Vinson Massif is a peak. All of you got it. This Transantarctic mountain mein, southern part as a volcano here called Mount Erebus. Active volcano. Volcano. Okay, Ross ice shelf. Now I am going to mention about this. Okay, so now all of you know Mount Erebus. Next to Mount Erebus is ice shelf. We'll discuss this. What is this? Let's say this is the continent. All of you notice Antarctica. Antarctica is surrounded by water here. Antarctic Ocean here. All of you pay attention. This is the mass of ice I am talking about. Large mass of ice. In Antarctica, the slope is two sides. One is this side and other one is this side. From the mountain, see this is a mountain. This acts as a glacial divide, water divide. Just like water divide, glacial divide. This glacier goes this side. This glacier goes this side. This glacier is slowly moving because of the slope towards the ocean here. This glacier is also moving towards the ocean here. The glacier initially is a large mass of ice, so its momentum is very low. It is moving very slowly. Per year 30 centimeter, that's it. Per year 30 centimeter. So first year it's here, then gradually it comes here after few years, then it is here like this. Since it is a continuous mass of ice, after few years the glacier comes here like this. Since it is a continuous mass of ice, it has support from behind. Just like, let's say you keep something like this. Since it is moving slowly, it has support from behind. So this part is hanging over the water. This entire thing is called as a glacier. This part of the glacier hanging over the water in a delicate balance is called as ice shelf, which can break anytime. Correct? Because of the weight, there is no support from below. So one day that front part will break. This part will break and falls into the water. Then it is called as iceberg. So the ice shelf is given in different color in your atlas. Notice this. Around this we have ice shelf. Notice ice shelf around Antarctica. You have a lot of ice shelves around Antarctica. Slowly all this ice shelf is breaking day by day, every day. And they are becoming iceberg. So write that diagram also. What is ice shelf? Now you know. The hanging part of the glacier. The front part of the glacier which is hanging over the water is called as ice shelf. The broken part is called as iceberg. There was, what is ice shelf? What is iceberg? What is the difference? The ice mass floating in the water, iceberg. The hanging part of the glacier, ice shelf. Check the color please. Ice shelf has some grey color. What is this? Grey, indigo, surrounded. Here also, Lambert, Larsen. This is Larsen ice shelf. surrounding Antarctica, you can see. Surrounding Antarctica. Here, see. Go like this. Around Antarctica, you can see the ice shelf. So that means Antarctica ice is slowly going towards the oceans. Oceans surrounding. Okay, all of you got it? What is ice shelf? Don't confuse ice shelf with ice sheet. In one question, what they did, purposefully, they asked first statement on ice sheet. Second statement on ice shelf. And confused everyone. You got it? Both the words almost similar, appear similar, but ice sheet is what? Large mass of ice with more than 50,000 square kilometer area. That is ice sheet. Ice shelf is a part of the glacier hanging over the water. Slowly, don't you think the waves, sea waves here, the waves of the ocean will act on it from below? Sunlight from above. Sunlight also. Slowly, this part will break because of its own load and falls into the water. Once it falls, it becomes iceberg and starts floating around. It is a threat to the ships. Any ship colliding with the iceberg might sink. Okay, I'll show you the iceberg photo. You see here how it looks. Okay, what you see on top is just only small portion. There is 1/9 part of it. Majority part is below. You got it? Majority part is below. Only 10% of the iceberg you are seeing on the surface, but most of it is below. 90% is below the water, floating. Why does ice float? That is another question now. Because ice has low density than the surrounding water. Ice has low density than the surrounding water. Okay, please remember this. I'll tell you that here. So normal water is what? Dihydrogen oxide. So the atomic arrangement, if you notice, one oxygen atom will have two hydrogen atoms attached like this. Okay, then again like this, haphazardly arranged like this, and water has a weak bond so that you can easily separate the molecules. Okay, normal liquid water has a weak bond. Okay, so one oxygen atom and two hydrogen atoms you can see on either side like this. When it starts to freeze, when the ice is formed, that is when it starts to become solid, what happens? The molecular arrangement changes. It becomes something like this. So entire molecules arrange in hexagonal lattice form like this. So random arrangement to see the arrangement, hexagonal lattice structure it will attain when it forms ice. The molecular arrangement becomes like this. During this, the volume increases. Okay, we all know density is equal to mass by volume. Ice has higher volume than the regular water. So volume increases by 9% nearly. When the volume increases, density comes down. Because density and volume are inversely related. Density is mass by volume. When the volume of ice increases, density comes down. So the ice has lower density than the surrounding water, making it to float. Okay. So understand how the liquid water molecules look like and how the solid ice looks like. So that is the reason ice has a stronger bond. Solid have a stronger. That is the reason it's very difficult to break the ice. Sometimes you take ice cubes, you try to bite, it is very difficult. Why? Because it has stronger bond. Arrangement, you notice how it is. So when the ice forms, volume increases, reducing its density, making it to float. So that is an ice floats. Let's say next time you take glass water, you put some iceberg, small ice cubes. You notice it floats on the water. Okay, you might have done that already. Okay, so when you put water and then ice on top, so it will float. Otherwise, sometimes you have taken glass. First you put ice, then you put water. Correct. Then the situation is different. Okay, because then ice slowly comes up. Have you noticed? Ice cube starts floating slowly because ice is lower in density than the water. Okay, so please remember this. So that is the reason ice tends to float on the water. Icebergs, pieces of ice and all around the ocean, they keep floating. This kind of icebergs are also there near Greenland. Remember yesterday's North America, Greenland, Iceland. There also. There also we have glaciers and ice starts floating there also. Icebergs. Labrador Sea. Okay. So please remember this. Now you know around surrounding Antarctica we have a lot of ice. See, next you should know here. Notice this. In 1911, Norwegian explorer by the name Roald Amundsen was the first to reach South Pole. Was the first to reach South Pole. He is the one who explored Antarctica. He was a Norwegian explorer. He is the first person to go to North Pole also. He is the first person to reach South Pole also. Okay. North Pole, Arctic Ocean. Antarctic Ocean here, South Pole. So, who is the first person to reach South Pole or North Pole? Roald Amundsen in 1911. So, he is the one who crossed Antarctica. Okay, Norwegian explorer. After that, a lot of other explorers came to Antarctica. So, they all realized, okay, there is a mass of ice. Below that ice is land. So, there is a lot of resources. Correct. Here we have just land, rocks, minerals and all. But here, mass of ice. Below that, glacier, rocks, minerals and all. So they started exploring. So after the World War II, many countries started colonizing Antarctica. They started setting up bases, research bases. In the name of research, they started colonizing Antarctica. Means this is ours, Anta. So the Cold War entered here after the World War. USSR ka Cold War entered here also. So many bases are US bases and Russian bases here. If you notice close to South Pole, you'll notice Amundsen base. It belongs to US. Notice almost they have already reached and colonized South Pole. Near to this, another base called Ostok, Russian base. Ostok base. Notice these two bases now. Like that, these two countries started colonizing first. Then came China. Then France, UK. These countries also started colonizing. You got it? So this became another headache for us. So in 1959, UN intervened and they forced all the country to sign Antarctica Treaty. Antarctica Treaty. By then, see, 1945 onwards, they all started to colonize. Means started forming bases and all. And many countries had already explored where is oil, where is natural gas, where is diamond, where is gold anta. See, we are all running after resources. Even today, if you ask me what research are we doing in Antarctica, resources, indirectly. Most of the countries are waiting for this ice to melt. They are happy about global warming. If you ask me, really, you take US, you take France, you take big countries, big economies who want to make money. Correct, who always think of resources. They want Antarctica to vanish, ice to vanish, so that they can exploit the resources. So in 1959, UN intervened and forced all the countries to sign Antarctica Treaty. As per this treaty, Antarctica is a continent for science, research and tourism. Means as a tourist you can go. As a researcher you can go here. Okay, you can conduct science experiments, but you are not supposed to claim any territory as your own. So the resources of Antarctica belongs to the mankind. So that treaty is Antarctica Treaty. So this treaty rules Antarctica as continent for science, research and tourism. See, this comes under UN. As a result, ICJ. Any party violating it, the opposite party can file a case on them at International Court of Justice. But nobody is there to monitor here. That is the other part. Okay. So Antarctica today has become a hub of dark science. Many, let's say, experiments that we can't do here. Let's say on chemical, biological weapons, nuclear weapons that we can't do here are done here in Antarctica. We call it as black biology related experiment or dark science experiments are done in Antarctica now. So many countries like Ostok base, Amundsen base, they don't even allow outsiders to visit these places. So as a result, a lot of illegal activities take place now in Antarctica, especially related to dark science. Okay, chemical, biological, nuclear experiments have been done in Antarctica. Antarctica doesn't have even a single tree. It is a continent without a single tree because it's a cold desert. Okay, so no vegetation as such. On the shores of Antarctica, we have seen some mosses, lichens growing, small plants, grasses growing. Otherwise, no plants, major plants. But Antarctica is home to penguins. Correct. Many subspecies of penguins can be seen across Antarctica. Penguin, all of you know penguin. Okay. Penguins are here in Antarctica. Walrus, seal, sea lion. Correct. All these species can be found on surrounding sites of the Antarctica here. What I was saying, Antarctica Treaty. This treaty rules Antarctica as continent for science, research and tourism. Okay. So initially India didn't have funds to start research. But we started in 1980. Locate Dakshin Gangotri, DG. 1980. Then Maitri, 1990. Now Bharati in 2012 or 2012 onwards. Bharati. Dakshin Gangotri, Maitri, Bharati. DG is Dakshin Gangotri. What is Gangotri? Remember Gangotri? Our glacier in Uttarakhand. This is in south, Dakshin Gangotri. Maitri is India's collaboration with other countries. So Maitri means what? Collaboration. So these are the three research bases of India in Antarctica. As of now, DG is supply base. Maitri and Bharati are operational. See, this research is done by organization called National Center for Polar and Oceanic Research, WASCO, Goa. Okay, I'll repeat here, all of you. In Goa, there is a place called Wasco, like Vasco da Gama, the place name, Wasco. There is an organization called National Center for Polar and Oceanic Research. Okay, National Center for Polar and Oceanic Research. What is polar? Arctic, Antarctic. Polar. Ocean, related to ocean. National Center for Polar and Oceanic Research. Any research related to ocean, any research related to the poles, it is done by this agency. They are the one who have built Himadri. Remember Himadri base in the Arctic. This one also. So please remember NCPOR. Locate Bharati. Locate. It comes near here. Lambert Glacier ke paas. Okay, near Ameri base of Australia. Very close to Ameri base of Australia here. There is a glacier called Lambert Glacier. Dekho. Lambert is the longest glacier in the world. Lambert Glacier. Yahan pe. Lambert Glacier. Below that is Ameri, Australia ka. Below that is India. Bharati. Okay. Ameri is not given. Okay, but there only you can mark. Orient Black Swan Atlas. Anyone with Orient Black Swan? There they have given. Given? Check that atlas. Orient Black Swan they have given. Bharati. Sometimes your atlas is not given. You have to check other atlas during the break. Okay. See, this is Bharati. See how it looks. Okay. So the glaciers are moving down, right? When it reaches the sea, what happens? The iceberg is formed. So the research base is also pushed into the water. So we have designed it like a ship so it can float. It has propellers also, turbines also here. So which can propel it to a newer place. We can put it in a newer place after this. Okay, that is the reason it is designed like a ship. Okay. As here, Bharati. This is Lambert Glacier, south of that. Clear? So please remember this Antarctica part. They'll ask water bodies. They can ask. They can ask ice shelf. They can ask our research centers. Okay. See below this Lambert Glacier, Larsman Hills. Anything is given? Larsman Hills not given. Notice Ostok. Ostok base. I'll show you that. Ostok. Ostok base. Below that Ostok, there is a lake Ostok. Antarctica. It is a subglacial lake. All of you understand what is subglacial? You notice now. This is the ice. This is Antarctica. The soil color, you know, Antarctica. Antarctica के ऊपर ice. This ice. See, almost like 2.2 miles, means almost 4 kilometers of ice. Below that, there is a lake. Lake hai, lake. That is Ostok Lake. Exactly here is a Ostok base. Above that is a Ostok research base. Ostok research base. So Lake Ostok is what? Subglacial lake. Below the glacial, we have a lake. Subglacial. They drilled. We call it as ice core. So what they do, they drill just like borewell, you know, borewell. Just like that, borewell, they bore the ice. When you bore the ice, you'll get ice core. We call it as ice core. Many millions of years old ice is below here. Let's say 65, 66 million years old ice will be here. Today's ice will be here. Fresh snow will be falling on top. The oldest ice will be at the bottom. So when you drill through this, you will get an ice core. They extract that and they study. So we'll understand how was the climate of the world earlier during Gondwana. Okay, how it is now. That we'll come to know. Glaciers leave behind some sediments, moraines, tillate. That also will give us about their path, movement also. How they are moving. Like that we are conducting. Okay, research on Antarctica. You can see this is the Vostok station. This is a bore I told you about. Ice core they have extracted. Lakhs of years old ice. See, old ice. New ice here. Okay. New ice, old ice. So a lot of pathogens, bacteria, viruses will be trapped in the ice. That also will come to know. Now because of global warming, what is happening? They all are becoming active now. See these pathogens, microbial life earlier, which was trapped in ice, they'll become dormant. They'll become dormant in ice. But suddenly, when the ice melts, what happens? They all are exposed to the air, atmosphere. The global warming can activate most of them. So in future, we are going to face new pathogens, correct? And new viruses, new zoonotic diseases. Zoonotic diseases are those diseases which spread from animals to humans and spread among us, like COVID. COVID was a zoonotic disease. Zoo means what? Animals. Zoo. Zoonotic diseases. So that is again something that we have to worry about. So this is the lake. Ostok. So this is the largest lake of. See, they have given subglacial Ostok system. Ostok is a subglacial lake.